All right. Hey, everyone. Welcome to this second episode of NGBE Live. In this episode, we have Jan-Niklas Wortmann, who will be talking about RxJS operators. And we have Michael Hladky, who will teach us about zoneless, high-performing Angular applications. Welcome, Jan-Niklas and Michael.
Hey, hey. Hi.
But before we kick off, let's meet our panelists for today. We have Yannick Houbrix, Mateus Carniatto, Maarten Tibau, and Sam Vloeberghs. Welcome. So Jan-Niklas is an enterprise consultant with a vast experience designing and implementing large-scale applications. He's also a member of the RxJS core team and an Angular GDE with a passion for developing clean and maintainable code. In this talk, Jan-Niklas will dive into RxJS operators. While most of us already use RxJS operators, Jan-Niklas will take us through their internals and teach us how they work and how to even write our own. Jan-Niklas has agreed to taking questions after this talk. So if you want to ask any questions, you can put your comments and questions in the YouTube page, and then our panelists will pick them up and ask them to Jan-Niklas in the Q&A section. So with that, please give it up for Jan-Niklas Wortmann.
Thank you very much for this nice introduction. And while Sam is dealing with StreamYard, we can start. So one question to start with, actually, just to give you an idea, would be to repeat all the surnames, because I think like this crowd has the most difficult surnames to pronounce. Let's talk about RxJS. So this talk is about operators in RxJS. And my assumption behind this talk is pretty much like everyone knows about operators. Like everyone that uses Angular already, to some extent in his or her daily work, use RxJS operators. But the internals of that are fairly unfamiliar. And this often causes certain problems. Like, for example, there's this often use case why you have to use take until as the very last operator in your pipeline and stuff like that. And informations like that will be covered by this talk. And when I started to try to explain, okay, what actually is an operator? Me as a professional consultant, the first thing I do is going to Wikipedia to look for someone that is smarter than I to explain that to me. And Wikipedia says about operator that an operator is generally a mapping that acts on elements of a space to produce elements of another space. While this is a fairly mathematical description of what an operator is, it still describes it fairly well already. It says it's taking something, does something with that to produce something different. That's more or less a less mathematical translation of that. And this is what operators are about in the gist, and what I want to talk about in this talk. First, pretty much all of this was already mentioned. I'm enterprise consultant for Evora IT, RxJS core team member, Angular GDE. Yeah. One thing before we dive really deep into this talk, one thing to mention is that some of the things that I mentioned here are heavy implementation details. And I'm showing that to you not to show you, oh, you can use it in your application and you should. No, it's more to give you the knowledge to build your application with this knowledge, not with the implementation details. It's kind of like not using RxJS/internal. So first of all, let's take a look at the interfaces that RxJS provides to describe operators. The very first thing we have is a unary function, which is just a higher order function. So it's a function that takes a source of some kind of T and returns some kind of R. That's it already. An operator function then is the same thing as it's still a unary function, just the fact that it takes an observable source and returns an observable R value. There's one nice helper function that is a monotype operator where the input value and the output value is the same, for example, for filter, right? Filter does not manipulate the output observable. It just manipulates the emission of values. So while interfaces and looking at code is already very technical, I want to take a step back now. And I want to talk about operators as the entity itself. And to give a rough definition, from my point of view, an operator needs to have these two key characteristics. it needs to be composable, and it needs to add some kind of behavior. So let's talk about operators. So one very common example for an operator is the map operator, right? We probably use it, or at least we know array map. What it does, it takes a projection function, it applies that function to every value that is emitted over that observable and returns a new observable out of that. And this is a good example for an operator, right? It adds behavior to our source observable in terms that, in this case, our mapping function. And it's also composable because I can apply operators before and after that without any kind of problem. From is not really an operator. From is not an operator because it does not add behavior to an existing observable. It creates a new observable, so it's like a helper method for us provided by the RxJS library, but it's not an operator per se. The same goes, not exactly the same, but kind of similar, it goes for multicast, right? So multicast has signatures where it returns the connectable observable. And the connectable observable is not composable. You have to call connect on it instead, and you cannot apply other operators. If you're using a different signature of multicast, where you have the selector, then you get an observable out of that, and you're good to go. This is composable. This is a nice operator. Actually, as small side note here, the multicasting operators are reworked in general as well, so that you don't have to deal with this SICAG anymore. But this is more like a side information. To sum up what I just said, from my point of view, there are 6 responsibilities of an operator. It basically has to handle all the emissions, next error complete. It needs to handle subscription to the source observable and as well unsubscription to the source observable. And it returns a new observable so that we are aligned with the signature. This already brings us, now that we have all the key characteristics of an operator, this already brings us to the pipe architecture. And the pipe architecture was introduced with RxJS 5.5. I quickly want to recap that an operator function is just a function that takes a source observable and returns an observable. Therefore, if we apply this mechanism, we can always pass the source observable as argument to the operator. Therefore, code like shown here on the right is completely valid RxJS code. So we can always pass the source as argument. And therefore, you have an inverted function call. This is complete valid RxJS code. No one is able to read that or maintain that. And this is where the pipe architecture came into play. The pipe method pretty much just inverts this function call to make it more readable. It takes the return value of the first function and passes it to the next function. And this is all what this pipe method does. More or less, I limited or I reduced 2 or 3 performance optimization, but it's pretty much a reduced statement of all the functions passed to it, executing them in the order. There are 2 more benefits that I did not mention here. Initially, and first of all, the main reason why we introduced the pipe architecture was due to trace checkability. Who used RxJS before version 5.5 remembers that the approach we had there was not tree checkable at all. This is the biggest and the main benefit we had. I mentioned the readability. From my point of view, having this pipe method allows us to write code in a much more functional way than before. And one thing that is not mentioned before is the extensibility, because the pipe method as well makes it much easier compared to before to write custom operators. And while I will talk about custom operators later again, I want to circle back to this statement. Every operator returns a new observable. Sounds about right. And if that's true, we can do stuff like that, right? We can instead, usually we are used to, when we're using with subject, we're just using as observable always, right? We can pass it to switch map as observable, we can use it in take until and pass it as observable. But if every operator returns a new observable, then I could also leave this as observable. I can just ignore it, right? Because it's returning an observable anyway. If this is true, then this is weird. While I'm applying an operator to an observable and do stuff on that, it's returning me an observable instance. But when I apply operators on a subject instance, at compile time, it says to me it's an observable. At runtime, it says it's an anonymous subject. This is kind of weird and seems buggy. And actually, this is due to the lift architecture. The lift architecture was the big thing of RxJS 5.0 and initially gained a huge performance boost compared to version 4. But in general, it consists out of these 3 entities. So we have source lift, the operator class, and operator subscriber. Let's start with source lift. And I will take the map operator again because it's fairly comprehensible. And I will explain how the lift architecture works in example of the map operator. So we still have the projection function here. And we see the signature again that was shown before. So we have the function that is returned that takes a source observable and returns another observable. And what's now happening is that it's just returning source lift, where we pass a new instance of a so-called map operator. So source is an observable. So source lift means there is an instance method called lift on the observable prototype. Let's take a look into this. And what's happening here is already that we are returning a new observable, and we are creating a new observable, and we're returning a new observable. This means the statement, every operator returns a new observable as long as it's using lift, seems to be right. Additionally, we have these 2 metadata, source, that is more for the subscription interesting, and operator. Operator is actually also called later in the subscribe method to check, and this is also the reason why operators operate. Operators operate lazily. Good in English. So just to recap, this operator metadata field is filled in the lift method and is pulled in the subscribe method to execute this operator then. We talked about lift, or at least the lift method. Let's talk about the operator class, which is the pass to this lift method. And the operator class is defined by an interface that defines a call method. Therefore, every operator class needs to implement this call method that takes a subscriber and a source observable and returns a teardown logic. In terms of map, this looks like that. So what we have here is a basic constructor that takes the argument of the map operator. So we have our projection function and this argument, even though no one needs that. And we have the call method. What we do in the call method is we're calling source.subscribe. So we're subscribing to our source observable. And then we're creating a new map subscriber where we pass the subscriber we get to this, the projection function, and the this argument. So all the logic that happens within the map operator by now is just pass values through to another instance that takes care of it. And in the end, the map subscriber takes care of all the logic that is relevant for this very operator. So it's a little bit small, I agree to it, but this is actually all the code that is inside the map operator. So we have this argument again and all the values, not that necessary. What is important to notice here is that we are extending subscriber because this ensures that next error and complete are at least handled and passed through. If we would not handle next error, handle at least all those values, then operators would act blocking. So imagine you're applying an operator that would not handle next. What happens is that the next operator would not get these omissions, not at all. So this is like the basic primitive that we had to ensure here. On top of that, we are calling underscore next, which is just a private implementation, which is called inside the next handler. And this is where the logic for this operator takes place. So what we're doing is we're calling the projection function. It's important that we wrap this in a try-catch here, because imagine you're passing a function through the RxJS codebase and this function throws an error. What you would expect, and what RxJS takes care of in that case, is that it catches that error and passes it through the error channel. And on top of that, we're also taking care of this count value, which is like the index value that you get passed in the callback function of map. And this is all what map does in the end, right? I want to mention here really quick that these things slightly changed in the meantime since I prepared that talk. I think like 4 weeks ago, something like that. Ben prepared a huge PR with 103 commits, refactoring a lot of the operators. And I think by now he minimized the bundle size by more than 50% of the overall RxJS library. So I can really recommend checking out that pull request. Very interesting, but the general concept still applies, just some of the logics are refactored in a more general way. Okay, back to the original problem, what was weird, and why is this still weird? We said, or we also saw in observable.lift, we are creating a new observable and we're returning a new observable. So why do we get an anonymous subject here? The thing is, while observable implements a lift method, the subject also implements a lift method. And in the subject class, we see the creation of the anonymous subject and the return of subject. This is kind of a typing quirk and kind of a bug. It is on our agenda, but to make it a non-breaking change is actually not that easy. So we are working on that. But this is one of the reasons why, or this is the reason why you still should consider using as observable and apply operators on the observable instance, not on the subject instance. I already mentioned that the lift architecture was initially just introduced to make huge performance boost. And there's another nice benefit that comes with it. And this is actually the customizability, I guess is the word. What do I mean with that? So we see, or what we could use this for is actually creating our own observable types in like third-party libraries, for example. We could do this. This is exactly one of the things that I mentioned. The lift architecture, or lift method in general, is an internal implementation detail. But nevertheless, we can implement our own observable type, class, whatever, that adds behavior to the whole observable. In this example, I created a lock observable that wraps every operator that is passed to it in a so-called lock operator, and therefore adds the class name of the operator to it. And in the lock subscriber, we are logging out all the values that we get. How does this look if you would use that? You would actually see very well what happened on your observable instance. So you would see, okay, the map operator is doing that. Don't be confused by do operator. The operator class behind the tab operator is still called do. I think actually there was a pull request in the meantime to fix that. Anyway, you see really well how the operators are executed, when which one is executed, and what it does to the value that you're emitting. You can also use this to create third-party, or not third-party libraries, but browser extensions, for example, if you want to add debugging features to RxJS at runtime in the browser. This would be the central point in RxJS to hook into to add those kind of features. So this is pretty much all we have for operators in RxJS, if you ignore that we have a bazillion of operators. But like on a high level, this is how all of them works. So now I want to spend the last 3 hours on custom operators. And from my point of view, there are two different kinds of operators. So you can have convenient or alias operators or whatever, and you can have greenfield operators. Because convenient operators make much more sense from my point of view. Let's start with those. And I want to give an example why you might want to use convenient operators. So everyone does stuff like that, right? Like instead of using a magic string, we're assigning it to a constant so that we can read it better. Or also we are using functions to group or to make code execution more readable, more comprehensible. For some reasons, anonymous functions, though, are a fairly popular feature in the JavaScript ecosystem. So for some reasons, people don't like to specify the functions that they pass to reduce, for example. And even though I wrote this code a while ago, I have already no clue what it does. And I would at least need to sit a moment to comprehend it, understand what is going on and stuff like that. And for some reason with RxJS, it's even more crazy. And I can say this because I wrote this code that is shown here, and it's probably still running in production like that. When I saw that while I prepared that talk, this was pretty much my reaction to that. Because like, besides me, no one is even able to maintain this in some way. And even I, after some time, had to sit down a moment, was like, okay, yeah, it's doing that. And then we're going here and there. Weird, okay. So the thing I want to say, long story short, is give the things a proper name. And RxJS under the hood does this already all the time. Like, for example, the start with operator is nothing than a concat of a static value and then the source argument. Or a concat map is just a convenient operator for merge map that passes the concurrency parameter for it. Share, same example. It's just multicast with ref count, and it's not using pipe. So it's like this weird kind of syntax that I showed before. And I just want to recommend you to do the same. It will make your code way more readable. For example, if you ever struggled with when to use switch map and when to use another of those operators, I could recommend you doing a safe get operator, which says, okay, in terms of a HTTP GET request, it does switch map and it automatically applies the catch error operator on the inner observable. This is a nice convenient operator which forces you to use the proper operator in the proper situation and also mitigate certain pitfalls. Another thing is greenfield operators. And for greenfield operators, I already mentioned, like we have a bazillion of operators. I think by now we have 105 in the /operators package. If you consider that pairwise is partition is a weird one, so something like around 100 operators, not counting creation operators, from fetch, Ajax, etc., etc. If you really want to do custom operators, like completely from scratch, without using any of the operators that are within RxJS already, first of all, I'm super interested in what you're doing there. I would be very excited to see that. But if you're still saying like, no, this is the thing I want to do, I'm the last one that's blocking you from there. And for this, I want to recommend you this talk by Ben and Tracy from, I think, last year's NGCon. They went through the steps, what you have to do to write a custom operator. Some of the things I mentioned in this talk, but Ben can do this way more professional than I could ever do. So I do the best I can with redirecting you to his talk or their talk. That's all I got so far. I want to thank the whole NG Belgium team for having me. This is a lot of fun, and everyone knows that I love the NGBE conference. You can check out my slides with this QR code, kind of fancy, or this link, whatever. Thank you all for having me. If you have questions afterwards, there's a Q&A session, so I'm still around for Q&A, but you can also hit me on Twitter or poke me or whatever and drop me a message there. I'm happy to help out in terms of RxJS, Angular, whatever.
Thank you so much, Jan-Niklas. Wow, this is really awesome. Looking at the chat, if you have any questions and you want to ask any questions to Jan-Niklas, please add them to the chat on the YouTube page, and then we will pick it up for you. Meanwhile, do any of the panelists have any question?
I have one. It's more about like best practice, since you talk about creating operators and you have a lot of operators already. Would you recommend to, when you have a lot of RxJS in your code, to create your own operators just to make it more readable and clean up a little bit?
Yes, all the time.
Okay.
So, for example, what I did in one project is that we had polling mechanism. And the polling mechanism was used in just 2 places, but it was using the same logic. And it was fairly complex logic. And therefore, I already started to have it in one logic in one operator so that I can test it dedicatedly. I can reuse it in case there's a third polling popping up and stuff like that. And does this kind of answer your question? Because Michael is super nervous about his question, and I...
It does.
I'm not nervous. I was just sorry that I made noise.
How dare you?
This was my face. Yeah, I'm super interested in more details on hooking into Lift for those, for, let's say, DevTools things or other stuff.
So what you could do is basically monkey patching the Lift operator of the observable prototype. So you can take the observable as a prototype, right? And then wrap the whole Lift method in a new function to do whatever you want to do with that. Because the Lift operator or the Lift method is the central part. You get the operator in there, you can do whatever you want with that. And you get pretty much all the value, all the informations out of that.
Also regarding subscription time and this stuff, like do I have the subscribe hook there too?
So what you do have is in the operator class, you have the subscriber class. And
okay.
When this one is instantiated, then so ish, you get access to it. Not like that, but yes.
Okay. Do you have any implementations that I can go and look how you did it?
I actually could imagine that Nicholas Jameson RxJS bias based on that, but I never looked at it. So this would be my first guess, at least. And the log observable that I showed is actually in one of the RxJS tests somewhere. So I could check if there are some others. You know, I'm lazy, so I'm just taking code and just explain it. It's way easier than writing code on your own.
I see. Nice. Thanks.
So there are a few other questions on YouTube. For example, from Chaos Monster. What would be a good pattern to wrap a series of operators that I need to reuse every so often?
Am I the only one that does not get the question? I'm happy if anyone would elaborate on that, but I don't get it.
I think it means if you have like a pipe and you have 3 to 4 operators that you regularly use in a certain sequence, like would you create a custom operator for that does all of that work in one?
Okay. Yes. So if there are logic that is commonly used together, so like I showed with the switch map and the catch error together, I would totally recommend doing that. And what you can do is, naming wise, it's a little bit poorly named, but there's a pipe method in RxJS that you can import for stuff like that. And it's pretty much concatenating function call operators. So you could use that for that. I think in the safe get operator that I used, that I showed, I actually used that. At least I was to assume I used that. Naming wise, it might be a little bit confusing if you see return pipe. It looks weird, but it works fairly well.
All right, cool. Another question. What's your favorite state management framework, Jan-Niklas?
I definitely don't want to start a war here. So first of all, I most of the time just use RxJS plain, to be honest. There are scenarios where I recommend NGRX. I also like Akita a lot. So depending on the project, it's probably one of those three. But I usually always start with RxJS plain, and from there on see what works better for my use case. I've never heard of this Rx Angular thing that was mentioned before. What is that? I'm just poking Michael.
Maarten, you had a question?
Yes. So I always wanted to spend more time on RxJS, and if I really would find the time, even contribute if possible. But as with everything, for me, it's sometimes very complex. But what would be the best starting point to learn more about the internals of RxJS, or just the source in general? Because you now spoke in your talk about the map operator, which I guess is also like source code that you showed.
Yeah.
But what would be a good thing to start on?
I think the best way to contribute right now is probably in adding tests. I'm not saying that we have a bad test situation or anything. I think we are like at 97% test coverage or something like that. But in the end, tests are also making sure that behavior we once added still works in the other versions. So for example, where we added a test recently is what happens if you pass a string number to take, because you're using JavaScript like a maniac, but technically you can just pass string 1 to take. And the implementation of RxJS 6 did not allow that. The implementation of RxJS 7 does allow that. And when we have a test for that, we make sure that the upcoming versions will support that too.
What's the testing framework that's being used?
I think Mocha, But
the test runner? Sorry.
No, you're fine. I honestly don't know. It's definitely not Jest or Karma. None of those two.
Okay, never mind.
But
thank you for your answer.
You're welcome.
I will have a look.
Cool. Looking forward to it.
Okay, cool. I think that those were the questions.
I would have a last one.
Okay, cool.
If I can. No. I'm interested. Thanks, Jan. As always, very kind. No, a serious one regarding testing. So I did a lot of tests recently, and first of all, I have to say I have not that much experience with testing, so I just went for 100% test coverage and was assuming, okay, it is more or less-ish the best. Then I figured out about testing synchronous and asynchronous stuff differently. Then I figured out about how long the list is. And now the question that I want to ask regarding the RxJS library testing: are you also using some MCDC scale where you already also test like combinations of parameters that you insert? So like all different variations of the parameters that you can pass to an operator?
I think so. Definitely to some extent. And this is actually where the test scheduler comes in really handy for us in the use cases, because we can also then test when the subscription takes place and stuff like that. I'm not sure. I think the 97% that I saw is on line coverage, basic. Yes, 97. I would have to check to what extent we're doing that. But I can promise you, particularly for the weirder the operator are, the more test cases we have.
Yes, I saw them. I read a lot of them. I also saw that you added recently the API surface coverage tests,
yes,
where you just check, and this is like really wonderful. I just took it over to a couple of my own projects. A really good idea. Yeah. I guess you picked it up from the Angular ecosystem. I'm exactly. Not sure. Yeah, pretty cool. Just wanted to mention that I really like it.
That's pretty cool to ensure that we're not breaking any stuff unintentionally.
Yes. All right. Thank you very much for the nice questions and conversations. If it's okay for you, Michael and Jurgen, we can continue.
Yeah, absolutely.
I'm fine.
I did have one final question, if allowed. for Jan-Niklas?
Absolutely.
Yeah. Okay. Awesome. I'll keep it very short. So the code that you showed there, the long page, it's very familiar, I guess, for many of us if we look at legacy code that we need to deal with. And one of the challenges I always find is like debugging RxJS. Like if you have something like that and it goes wrong along the way, like one event doesn't appear as expected, or how would you recommend troubleshooting? Do you is that like use the log operator that you just showed and put it there? Yeah, is that the way? Or
so I would add like tab and console log everywhere, honestly.
Okay.
And that's also how I never used RxJS by Nicholas Jameson. I can definitely imagine the crazier the things go that this might be really helpful. So far, my debugging problems worked out fairly well with tab and console log.
There's a term for it. I have to mention it now. I'm sorry. It's called TDD. It's not test-driven development. It's called tab-driven development.
I approve.
I even have a snippet to tab log my streams.
Brilliant. So okay,
nice.
But then
It's good to hear that even core team members use tab and console.log.
It's actually reassuring. Nice. So tab-driven development indeed. So thank you for introducing that term. Yeah, looking at the chat, it's blowing up with thanks. So thank you, Jan-Niklas, for sharing everything. This is really great. And thanks everyone for the great questions. Okay, awesome. Thank you so much. And thank you also, Michael, for asking questions and being very interactive in this in Jan-Niklas's presentation, which now, segues into you, Michael. Let me introduce you officially. So Michael Hladky, here on the call, is a Google developer expert, GDE, Microsoft MVP, a trainer and consultant with a focus on Angular and RxJS. For years, he has helped many companies and developers to set up scalable architectures and performing processes, enabling teams to keep up with state-of-the-art development. As a vibrant member of the tech community, you may have already met Michael in real life because he organizes multiple community events and workshops every year. Today, Michael is going to talk about the guts of Angular change detection and why Zone.js can sometimes work against us. He will share a trick on template bindings. He will tell us about component rendering, and he will teach us how to avoid blocking UIs by analyzing flame charge and leveraging task scheduling. If that doesn't get you fired up, then Michael's unique style definitely will. So Michael has also agreed to taking Q&A after his talk. So if you have any questions, you know the drill. Just go to the YouTube page and enter your questions right there, and we'll pick them up for you. Please give a huge round of applause. In the chat, you can do that as well. Give some applause for Michael Hladky.
Thank you. Okay, can you see my screen okay? Can I start? I assume I can start. Okay. Welcome to my talk, Fully Zoneless High Performance Rendering in Post-Ivy. And I will start with a little bit of an overview. What I will show you in this talk is historical information, fundamental information that you understand how Angular's rendering is working under the hood, is working currently, and what I want to change with it. Then I want to introduce two template helpers, push and let. I want to show you some other cool tricks with the viewport priority, another feature that I want to introduce today, and I want to talk a little bit about tricking zone and why it is really helpful. At the end, if I if I have enough time, I will speak about Rx if, switch, and for, and give some sneak peeks on my current experiments. Let's start with the punchline of this talk. The async pipe is boring. And I want to tell you why the async pipe is boring by starting with a design document from Miško. Miško, the creator of Angular, and you can find this design document online. And this design document talks about a certain change in the mental model of Angular's change detection system. And you can read there about how L views and containers are nested into each other. You will read about Mark 30 and scheduling techniques. You can read about Angular elements and their standalone change detection or local change detection. You read about significant performance benefits and, of course, about explicit state management or local state management. So all those buzzwords together is more or less the topic of this talk today. And I can promise I will do it even better than all those buzzwords together. First of all, a quick throwback to, for example, NGBE. Last year, I had the pleasure together with Jan-Niklas to open the conference and talk about reactive component state management or ephemeral state management. And this stuff helps us to get a very unorganized code into, first of all, very nice and clean organized code, and then in very performant code to manage or like to provide the reactive clue within components. I don't want to go too much in detail with this. Check out the library rxangular/state and you will see what I mean. As a quick teaser, you can turn a lot of code into little code, and you can also do a lot of tricks. And I want to give a first small demo on what you can do with this very lightweight state management tool by switching to a template structure. And if you look at this template structure, we have nested components, and this here is the change detection strategy. So we have one component with default. Within this component, we have one again with default and one with on push. And in the on push one, we have another child with on default and another one with on push on the left side. And if I click, for example, application ref tick, then you see the whole application renders down, and you can also, for example, do mark for check. This is what the async pipe would do, and so on. So I will later on come back to this screen and show you how change detection works. This was just to demonstrate the blinking values here and what they do. And now I will show you what you can do with the state, Rx Angular state. You could pass values, and Angular is doing this by default. So if you have a nested component structure and you want to pass a value to level 5 here, you will see you have to recheck and re-evaluate, and in some cases also re-render a couple of components. If you do this with Rx state and I increment the value, you see there is not a single change and not a single re-rendering, only at the very place where you want it. And this is done by handing over the observable directly through input bindings of components. But as this is related to state, I want to keep it with that small demo. Here is the docs, check it out if you like. And I want to go on with the real topic, the guts of Angular's rendering and change detection. And I want to start with template rendering and the component tree. So this is an application. We have the application reference at the top in blue. This was also the purple big circle that you saw in the demo. And then we have a lot of components. And here we see in a mockup a side menu with menu items. And then on the other side, list items in a list. And if I turn this into a tree structure, it looks like that. So on the application reference, the application component is hanging, and then all the other child components in a tree structure below it. And if I call application ref tick, Angular starts to render the first component, then its children, then its children, and then its children. And if I click it again, it would re-evaluate and re-render also their templates, if there are any changes, which is not really performant if you ask, well, pretty much everybody out there. Therefore, Angular introduced on push, and Angular said, like, well, if you want to have a performant or more performant, better change detection, faster change detection, please use on push strategy on your components. And if you do that, and this is signaled here with this light gray triangle that turned now into a black gray triangle, because if I switch back, so when I render the component, and then I come to this very component, I evaluate, and on push just looks if the previous value is equal to the current value. And if it is equal, it does nothing. It skips the whole left tree, and I will go on, not I, but Angular will go on with rendering the other components. And now the solution for every problem in your life: use the async pipe everywhere, and on push change detection in any component, and all your problems are solved, right? Well, I believe no. Otherwise, there wouldn't be that many applications out there that suffer from performance problems. So what's the problem here? If I want to introduce a change to this purple component here, and I do this, and I did not pass on push for every component, I will re-evaluate all those yellow marked components here. You can say, I am smart. I will introduce a linting rule that ensures that I set the on push change detection on every component. Well, sorry, but what if you use third-party libraries, especially some from Angular material, for example? Well, then you are screwed. And if this is also not the case, then you are still screwed, because it will mark all the components up to the top 30 and has to at least re-evaluate all those components again and again and again. And as I showed you before with this passing values demo, we really see that it has to re-evaluate all the components compared to the other strategy where we directly passed the value through all those layers with the state. So this is very sad and a big problem, and I'm here to solve this problem. My name is Michael Hladky. I'm a custom trainer. Yeah, I'm a custom trainer, and I'm a custom consultant, and I do custom workshops for every customer that comes to me. And as I messed up my introduction, I will go on and fix your problem about rendering. How to fix those imperformant rendering techniques and processes. Well, first, let me show you, let's go back to this demo from before and to this nested component structure. And here I compare projected structures and nested structures, but let's stick with the nested ones. If I say, okay, I use change detection on push everywhere and the async pipe, then I still have this performance drawback, because I can demo it now. Even if I fire the async pipe in this very component here, I will re-evaluate also all on push components, because somehow the values need to find their way to the actual component. And what one of the first things that I did with all those performance optimizations was I switched to detect changes. And as you can see, detect changes is only rendering the very component and nothing else. So how did I do that, and what are the implementation details? If you want to just try it out and want to quit the talk from now on, you can do that. You just install rxangular/template, and you will get a quite good set of helpers that enable you to write fully zone agnostic applications. It's not zoneless. It is like it gains the performance of zoneless applications in zone full applications. So it is zone agnostic. And this library ships two different things. This library ships a push and a let directive, a push pipe and a let directive. And the push pipe is basically a replacement of the async pipe, which uses detect changes under the hood instead of mark for check, as I showed you before. And the let directive does the same thing, but it binds the observable values and also the full observable context, which is next error complete. And in RxAngular, we have also a fourth reactive state, which is suspense, to the template, and you can configure it. And I want to quickly give you a demo on how you can use it. And I want to first show you the bad implementation. So here I add async, and let me quickly add some strings here that I don't want to explain. And I go to the let directive and to the ng ifhack, I get an error because I wrote asyn and I need to write async. But if I do that and the Angular application recompiles and reloads, I can again navigate to this point here and then I see it. And here, if I click the button and then switch away, we see that there is a true or a false value. And this is now done with the async pipe and a normal button here. But if the button is basically zoneless and will not trigger any changes, I can click this button as often as I want, and I will see no change happening here. So what you can do is you can switch to change detection on push, and on push works in pretty much every Angular application with zone or without zone, and it will only perform change detection on the very component with detect changes, and we can see that if I click the button, only the component number goes up and not the full application. So this is one thing that we can do, and we can also use this by applying the value to a template scope. And here I use the ng ifhack to use an observable and the push pipe to re-render this small template snippet. And if I do that and I click the button and switch the value from true to false, we see that only truthy values get rendered. And this is a same sad problem and very annoying. So what we can do is we can switch to the helper directive RxLet. I directly pass the observable, and then I can also render the values here. And let me quickly copy the new text so that I also have the proper feedback in the template, and I re-render it, and we should see now truthy and falsy values, which is pretty cool. And I can do even more. In fact, RxLet has a couple of features that you can see here. We have the full reactive context, we have error, we have complete, we have next, we have suspense as a value. And we could use them in the template here and render them, but way more interesting are all the templates. I can say, this is my default template, and in suspense state, we want to see something else. In error state, we want to see something else. And in complete state, we want to see something else. And I hope that the demo is still running. Yes. So this is the suspense state. No emission took place, so I can show a loading spinner or these ghost elements that I use here. And only if the value arrives, I will display some information. Same goes for error messages, so I can provide a separate template for error messages as well as the complete signal. Pretty cool. And you can use this template for a shitload of things. You can do proper error handling where you have a loading state for your form. You can initialize your form. You can type stuff. And even if the form throws an error, you can also apply styling for this error. You can also do image preloading, for example, where you go and delay an image and have a preloading state. Or what you also can do is you can lazy load components. You can lazy load components without using async await. And today I tweeted how bad it is to use async await in the template. Here you can see it in action, lazy loading of components in 2 lines of code. And I quickly maybe show you the lines of code so that you really believe me. And here we go. This is all the code I use 2 times an import function. And here in my template, I have the suspense state and my let directive, and I not use any async await technique at all. So pretty cool stuff with those 2 directives, but this is not all. I provide a couple, not I, Rx Angular, the team, the full team, everybody, every one of us provides a lot of other things, for example, rendering strategies. Rendering strategies, global and local, are the ones that I want to introduce to you, and you can implement them by just providing a string as strategy at the moment. in the future, we will ship fully configurable services on every layer in your application. But let's first start with the global strategy, and here I can use Mark 30. Mark 30 is basically the same thing what the async, what Mark for check would do in the async pipe, but it does not rely on zone. So if I introduce a change, it will mark all components for dirty, and then it will re-render all the components without relying on zone. But it will still re-evaluate, at least re-evaluate, if not even re-render a lot of components on their way. And this is, I guess, a very bad thing. And I want to demonstrate to you again how bad it is, because imagine you have a very heavy component like a table or something else in your in this level here, and then you go Mark 30, you still have to re-evaluate everything. And let's say if you would call it here, and the path would also be 3 components. If you use third-party libraries or you forget it, you even evaluate other components in your component tree, which is not really nice. And we really try to get the most out of our rendering. So I want to introduce to you a fully reactive change detection system, and the essence of it is the local strategy, which relies on detect changes. This can also be used in Angular Elements, and it works fully zone agnostic and gives you the maximum performance on rendering on component level. Under the hood, I will use an Ivy internal function, theta detect changes, and if I introduce a change, I will only and really only re-render those components that are marked here if I introduce a change. But if I would use it directly without introducing a lot of tricky things, I would end up in 12 re-renderings. 12 re-renderings and blocking UI. So I want to quickly introduce you to 2 techniques how I solved it. Scheduling. Scheduling is the first thing, and this is code that I want to split into work, the part that triggers a function, like a button click that triggers work, a function that is called XXX. And scheduling means triggering over a button click and moving the execution of this function onto another place in the event loop in the browser. And there are plenty of different scheduling techniques. I will not go into detail. I will use the microtask scheduling, which is the yellow part here, to explain to you coalescing. And coalescing under the hood leverage scheduling on a microtask. And a microtask is nearly synchronous code. I call it nearly synchronous code because you have synchronous code, and after all the synchronous code is done, you will be able to execute a micro, or you will execute the micro task and then all the other code. And we use this, and if we have a series of inputs and we pass all of those inputs into a function, and this function schedules the execution over a micro task, we could end up and filter out all the over-rendering that would happen. And therefore, if we schedule a function 3 times, pass it to our tracking fn, then we would re-render or execute this function only 1 time. And this is amazing and brought us a really good performance impact. But this is not enough, because I want to skip the demo because we don't have enough time. But this is not enough because you would still have 4 renderings for this very example, because there are 3 push pipes and also synchronous emissions in a row. As you look here, I have a from observable that emits 3 times synchronously in a row. And we would go down from 12 to 4, but we would still have this problem of multiple observables bound to our template. And therefore, we introduced coalescing on a scope. And in our case, the scope was the component. And this helped us to go down from 12 renderings to 1 single rendering and a non-blocking UI. So how did we do that? First of all, using detect changes avoids unnecessarily checking or, in worst case, re-rendering other components. We used coalescing to be more specific, scoped coalescing to go from 12 to 1 re-renderings. The number of over-renderings is now reduced. And we use at the moment different scheduling techniques like the animation frame or the post-task scheduler in very cutting, bleeding edge applications to have non-blocking user interfaces. And this is pretty amazing. And another thing that I want to quickly talk about, maybe I stick with the slides, is tricking zone. If you take a look in our library, you have another thing that is really, really helpful in creating highly performant applications. And this is the unpatch directive. Because if you click any button in an Angular application, it will trigger, even if the button calls avoid a noob function, Angular will re-evaluate the whole template. And this looks like that. This is just a app component, one component and a button and nothing else. And this is all the work you need to do by Angular natively. Well, there are people that say, I am smart, I will run all my code, and in this case, the button click outside of Angular by using ngzone, run outside of Angular, and you can get rid of a lot of code. And as you can see, it is at least five times faster. Well, Rx Angular thought this is not enough, and we played around a little bit, and we came up with another thing. We came up with the detach, the unpatch directive, and if you execute code in the unpatch directive, you will get only vanilla code. So we don't even use zone or rely in any way on zone or outside of Angular. We just execute only the vanilla code, and this is the fastest thing that you can get out of your Angular application. Otherwise, you would have to reduce the application code itself to get faster. And I guess this is a pretty good benchmark. Another very cool thing is the viewport priority, and the viewport priority is also quickly demoed here because we can do pretty cool stuff with it. We can say, I have a component, and this component here is updated. As you can see, if I click, there is some animation ongoing and there are updates. And this could be a live application with a lot of updates over time. And when I would hide this component or scroll it outside of my viewport, would it be necessary to re-render and recheck the component? I guess no. So if I scroll out the component, my change detection stops, as you can see here. And if I scroll the component in again, as you can see here, the change detection goes on and will re-render and re-evaluate and check the component. And this is really cool because it not only works in this viewport, but it also works in the whole browser viewport. So if I shrink the browser to hide it, also the ticking stops. And if I show it again, it starts again. This is a very, very cool and nice example on what future tricks that we are working on. This is a standalone directive that you can use at the moment already if you install the library, but we work on even cooler tricks under the hood, so stay tuned. And the last thing before I want to close up is a look ahead to all our future structural directives that we are crafting at the moment. They are called RxIf, RxSwitch, and RX4, and I'm pretty sure you know them. Just replace Rx with ng, nur in the Angular world. And we have another one that's called RxMatch, which is a special extension, or let's say a variation of Switch, a more rich API and a little bit more functionality. To explain why I'm so excited about this part, I want to go back to the component tree, and I want to tell you that there's this component tree. It exists out of components, and if I take a closer look at a component, under the hood, Ivy creates L container and L views and composes them together. And this is how the like microstructure of a component looks like, of the components template. I have a graphic here. This is like one component in my component tree. And if I zoom in a little bit, there is my view tree. And here I have L containers and L views. And wouldn't it be really cool if I receive a change that I could just change detect or re-render one of those L views that are hanging in the tree? wouldn't it be 10, 20 times more performant comparing it to re-evaluating the full component? Well, let me give you a last demo before I finish up this talk. And I go here and I close all the other items and I open structural directives. First, I want to demonstrate that we can toggle change detection on embedded view level. So the solid line is a component and the dashed lines are L views. And if I switch a value, here I use the Angular native way, I would re-render the whole component. If you look at the numbers here, this is Angular natively, and now I use the unpatched button, so I can also only evaluate those here. This is only checking changes on the embedded view. So here we have two different templates that are visible at the same time, that I change one time this, one time the other. Here I recreate and destroy this template under the hood. As you can see, the number of changes is always 1. And here I even used another cool technique. I have no time to go about this, but we use template or embedded view caching under the hood. And if you take a look about the numbers, I don't destroy and recreate the component. I just reuse it. And this brings a really nice performance boost in all display height logics. Final demo, and then I promise I am done. And I'm very, very excited about this demo because it really gives you a good look ahead where we are going with this library and why we not only claim why we are the fastest Angular library out there in terms of rendering and change detection. This is an array of 10 items, and every item has another array of 3 items, and all of those items have one value, a true or false value, which is a red cross or green check mark. And if I update Angular natively and I reassign a new array or update a new array, as you can see, the whole page gets re-evaluated, and I have to wait nearly 2 seconds until everything cools down. And I guess this is not really. So let me show you what we did with the RX4 proof of concept that at the moment has 3 new features. Track by is now a little bit different. Then we introduced distinct by, and we also introduced select. I cannot go into more detail because time, but let me show you. If I update a bunch of different items in an array, do you realize, and let me zoom in a little bit, that only and really only the templates that are affected re-render? Let me click the button and let's hope that there in the upper part are changes. Yeah. So as you can see, only the embedded views that are affected re-render. And now let me give you a small performance comparison. I switch to the native version. I open up my performance panel, click all changes, then I start recording, and I say Angular execute as fast as you can and reassign a new array as fast as you can. And as we can see here, the changes are introduced, I guess, every 1.5 to 2 seconds. The screen flashes and we get updates. Let me quickly stop that and also stop the recording. And let me switch to RX Angular 4 and do the same thing again. Here, the processing is still done, but no problem for me. I will, in the meantime, demonstrate the performance without measuring it, and later on we can take a look at the measurement. But let me click the button now, and as you can see, you really see and feel that it is way faster, and you get the updates way faster. So let me stop it now, click another recording and do another, let's say 1 to 3 seconds demo run of this, stop it and do the final comparison of our measurement. I hope this time the processing is a bit faster because I did it only for 1 to 2 seconds, and here we go. So our first measurement of updating the same value the same array in the same way looks like that. And if you take a look at those red bars here, this means that we have really, really bad performance, blocking UI, and also the frame rate dropped. Nearly every single frame is not really perfect, and also a lot of code executed. Let me switch to RX4 example. And as you can see here, beside the initialization, there is no blocking at all. And if we take a look, and we really have to zoom in, there is only the code executed that we need. And we can really count how many elements are here introducing a change. So this is, I guess, a really cool thing. And it proves that we are on our way to getting, we are now already the fastest frame library out there to render Angular. And as you can see, we are on our way to do really even better. And this is the last thing I want to say goodbye by saying a big thanks to all our contributors, especially to the core team members that spend way more time on the whole project than others. But thanks to every one of them. If you want to make us happy, give us a star on GitHub. Otherwise, just give it a try under RxAngular/template, install it, let us know how you like it, and that's it. Thanks for your time. Here again the link, and if you have any questions, feel free to ping me.
Wow. Thank you so much, Michael. I think everyone agrees that this was very, very impressive and insane to see those performance and improvements. I have many questions I would like to ask, but
I have a first one.
First.
How long did I took? I totally forgot to measure the time. Normally I do it to get a feedback. How many minutes was it?
I don't know.
Okay, you don't know. No problem.
35 minutes.
Okay, not that bad. I tried to land in 30.
Does that fall in the boundaries of Rx Angular improvements? 35 minutes.
It should, yeah. But now we get Ben's PR, so we get faster performance by just installing the latest version of RxJS. It will be huge for us, and so I don't need to adopt the 5 minutes, I believe. But I really look forward to this release of version 7. I cannot tell you how much. It's incredible.
Yeah, and indeed a lot of love in the chat as well. Like it's blowing up with love and people congratulating. Really awesome. That being said, so we have a first question already from Tim Platius. Do you have any advice on debugging rendering issues using the performance tab to see where the bottlenecks are?
Yeah, it depends what you want to debug. So I did a couple of dedicated performance optimizations with small and large companies in the last 6 months, and you should first decide what you want to improve on. You want to improve on Bootstrap performance, you want to improve on runtime performance. Those are two completely different topics which deserve completely different techniques. This is the first thing you should get a good idea of. You should have no real endpoints to have really reproducible stuff. Just fake your data, use fake delays, just have it as reproducible as possible. And you can install the Chrome DevTools and use them programmatically. This is a really advanced technique that we use, for example, to measure the performance of Rx Angular. We perform end-to-end tests and we directly connect to the browser's Chrome DevTools while we are running the end-to-end test. And start and stop the measurements there, and you can have really identical clicks and time stuff and compare them. There is the DevTools timeline viewer online that we are also using. Let me share some of our first measurements so that you can see how we document the stuff. It's pretty cool. And then a last thing. If you want to find specific points in your application, let me quickly paste the link. So here's the link. If you want to search for like, when did my component start to render and when did my component end to render, you could do it programmatically by setting markers in the DevTools, or what I do, I'm not that professional, I just name a function, start and stop, and then you can search. You can search in the flame charts, Control F, you search for start, whatever, and then it jumps, like the focus jumps to that specific block in your flame charts. If you want to see it, I can demo it later, but I don't want to waste time too much. And this and a shitload of more information you should know when analyzing the stuff. It will take a long time. I was like, yeah, I know flame charts and it's not that special. And after 6 months of like only doing that shit, I agree that I never ever understood anything about performance. I learned a lot. Yeah.
Awesome, and thanks for sharing that tip on the function.
Yeah,
that's actually very cool. Then you can so we can name our functions Michael and Hladky and find them
yeah.
really quickly in the flame chart.
The best tip is that you should use the the performance tools programmatically. It's incredible. You can control everything by code, and this is it was like I was incredibly excited after one of our core members added the PR. Of course, not I did the cool trick. Well, it's always somebody else, right? So, but I'm happy about it. I'm happy about it, and I cannot tell you how cool it will be, because we will automate everything, comparable, measured, scientifically proven.
Mm-hmm. Well, one thing that I will remember from this talk is your quote on the async pipe is boring.
Oh yeah.
Well, definitely sounds boring if we listen to your talk. So yeah. There was another question. Let me pop it up. So what's the best way to use the on-push strategy when using smart or dumb components? So the best way to use it is to use it on smart components, or?
The best way to use it is just use it everywhere. You will barely have a problem with it. One thing that is a problem at the moment, but will get fixed in the next at least three minor patch Angular releases, is transplanted views. So if you have a normal DOM structure and you don't use projection, like few port projections, then you have no problem. You can use it everywhere. If you work a lot with projections, the change detection is not intuitive. So you would assume changes bubbling down to this and that layer, but it is just looking like that. In fact, it hangs on another place in the component tree. This is tricky. And then in some cases, you can solve these problems by switching from on push to default. But believe me, this is such an edge case. I ran into it, I guess, once a year. And yeah. But this is the only thing where I would say you should not use it, or you have to switch away from it to solve a problem. Or if you want to work with mutable data, if you say I want to work with mutable data, you can also not use it. So what I would suggest, if you want to work with mutable data, which is a pretty interesting thing, because mutations are fast, right? And immutable data is slow. If you want to work with mutable data, I don't have demos here. This is a really interesting topic. You can pass the observable directly. The observable is the channel. The observable will be always the same instance. So you can have change detection on push. It will not re-evaluate because it is the same observable. But the values inside of the channel are different, right? So you can pass values everywhere in your application without re-evaluating stuff. The trick is done by the Rx State, which Jan helped me last year to develop some edge cases and solve a lot of low-level problems. So thanks again, Jan, for your help last year. With one of those tricks that we experimented last year, I did this direct value projection through the whole application without all the mess.
Nice. So I think we are inspiring some people here. Somebody has left already to go refactor a project, so that's very nice. And we also got mentioned that Joss's favorite quote is still tab-driven development.
Yeah. I believe it's no. I can tell you why I know it. It's also not my idea. give credits where it's due. I met a guy on NG Poland last year, and he came up with that in one of my workshops, and since then I loved it so much that I use it pretty much whenever I can. But also not my idea, just a copycat. I'm a good copycat.
Perhaps one final question from Maarten. Maarten, perhaps you can pose a question.
Yes. I'm just becoming such enthusiastic just by the sheer of enthusiasm in the talk, and I'm seeing all those things, and I'm almost the same like the guy you mentioned before. It's like, I need to use this. I'm gonna refactor certain stuff because it seems like a lot of these things just come for free. It's not a downside to just use it, but I would think that with all these benefits, because at this point in time I only see benefits, why would this not be something that would become incorporated in the Angular core library itself? Because for the RxJS, RxLet, that is something that Angular developers have been asking for maybe 2 years already. And there is
4 years.
Yeah.
There is an open issue. I posted there 100 of times. It's a perfect question. I love the question. You have more to say, or should I answer it?
No, you can answer it.
Okay. 3 things. Pretty much none of the Discover, the stuff that I showed will be applied to Angular. One of the most fundamental things here is Angular's change detection mechanism is pull-based. So you introduce a change by saying, okay, in this very component, I want to update. Then you mark the path to this component dirty, and then Angular goes top down. So you say, give me that, you pull it. So can I get the new data? Can I get the new data? You say, give me the new rendering. And then Angular gives the component a new rendering by going depth first to all the components. And this is pull-based. So you pull the rendering to you, which has, it's very technical, but there is a limit in scale, and this is how Angular is doing it. And all the changes that they will introduce after Ivy, like theta mark dirty and theta detect change, they still stick with pull-based change detection. So even if you have the full control, you can say detect changes now on that component. I mean, detect changes not, but mark dirty. If you say mark dirty this component, you still go up the tree and pull the rendering down to you. What I do is I introduced push-based architecture in the rendering, and this is a completely different thing, and brings me to the second thing why they will not adopt it. I use RxJS everywhere. It's basically a change detection based on RxJS, consisting out of 25 lines, I guess, scattered over the state and the template library. So it is no code at all. As Jan said, he uses for state management plain RxJS. I mean, if you know what you do, it's like 1-2 lines, you're done. You don't need any library. So a little bit of code is doing the change propagation for me. And the other stuff why it won't get adopted is I use a lot of structural directives. And there is one very interesting comment, because I had a couple of discussions and talks with Mishko, Minko, and other folks from the team. There is one comment in this issue online about the let directive, where Igor Mina says they will not implement it. They have to implement it in the compiler in Ivy because it will be too slow for nested structures. And one thing that I demonstrated you was nested structures today. So it is fucking slow with nested structures, but only if you stick to pull-based change detection. What I did, I just switched I indirected the whole responsibility, and I disproved Igor now officially, but still, I believe they will just hope that Rx Angular goes big enough and they can always use that library. We don't need to implement it now. It's just what I'm hoping. Gossip stuff. No.
Thank you.
Yeah, so I think Jurgen also has some questions.
Yes, I have some questions. I'm looking at the chat, so no further questions from the chat, which is good. So now I'll ask my questions before we kick off, before we drop off. Sorry. So in the beginning, Michael, you said that you talked about passing an observable by reference via property in a component.
Yeah.
Did I understand correctly? Is because I also always learned like that's not a good thing to do because it can introduce side effects outside of the component?
Exactly. Very, very good. So normally people say it's not a good thing because managing the composition of this observable and its subscription handling is a mess. But we have RxAngular/template, and there you have one line of code that says connect, and then you can just throw an observable in and it will automatically connect to your state, and all the edge cases are handled. So I use it everywhere in pretty big applications, and there are no problems because all the tricky parts are taken away. You don't even have to think about subscribing, right? You can write subscription-less code, and subscription handling beside error handling is one of the things where the most applications fail. So one thing that you don't need to care about.
Okay, thank you. So you'd say like, okay, it is allowed if you use RxAngular. You wouldn't do that.
That's a good saying. It's allowed if you use RxAngular. I cannot signed.
Got it. Yeah. Perfect. Second question was, can we get access to the RxAngular demos app that you used in the with the demos? Is it available?
Everything is open source. Under RxAngular, the repository, you can check it out and surf it. I will deploy it, I guess, tonight or tomorrow when I fixed a couple of other things. But I will also host it on GitHub pages. You can go there, click. You can disprove me. You can say, I don't trust you. It's not fast. I will go there and do my own performance measurements. Please do it. We would love so. So, yeah.
Awesome.
Try to disprove.
Thank you. Yeah, I also asked, like, does it work without and with Ivy?
Yes.
Like if you have older projects.
So the funny stuff, even if I use some of Ivy methods, for example, at Mark30, the real good thing, like the local change detection, was possible in RC3, I believe, of Angular. So since Angular 2 are a release candidate 3, this library would work because I don't use anything special. I just use plain RxJS and use the change detector ref detect changes, nothing else. One thing that was different before is LView, LContainer, and LEmbedded view. This concept took me a while to work with it and propagate the changes in there. But beside that, it will also work identical from the first version of Angular on. Viktor Savkin even, when he introduced the new change detection in Angular, he said you could easily implement reactive change detection on your own. He was right, but there is a couple of other things that you also have to consider, like a lot, not only this change detection thing, and therefore not a lot of people did it, but it was possible from the early versions on.
Wow, nice. So super nice that you guys are tackling this, and it's amazing to see how you can plug into it and actually make that happen. Is so super awesome. Thanks for sharing. One final question: are you, like you mentioned that this will never be part of Angular Core, but are you working together with Angular team on this? Are you like in close contact with them?
What I do is I try to read all of their documents, like design documents on their changes, and from time to time I have some sparring sessions with Minko, for example, but not we don't work on that, I would say. I'm very interested in this topic. They have it on the roadmap. There were some discussions that it is in the same area, the work that I do, but there is no official collaboration or nothing else.
Okay. But you would say that it's safe to use the library in a project, like if Angular 13 or 14 comes out and they have another change detection mechanism,
they can switch. They can switch to any other change detection mechanism. I don't use it. We use this built-in one, so as long as we don't change it, it will work.
Awesome. Yeah, thank you for answering the many questions.
Yeah, cool.
I'm looking at the chat. Lots of applause there. Many great thanks from all the people who were watching. So I think that, hearts indeed, applause, claps, thumbs up, everything. I think everyone is really excited to try this out probably later this evening.
We should also give a shout out to RxJS, the library itself, because it will bring us an incredible boost in the next version. And this is way more effort than Rx Angular stuff. So they also deserve a big shout out, I believe.
Yes, absolutely. Totally agree. And we should invite PANELISTS on the show here as well.
Yeah, you should.
Yeah, absolutely. So with that, thank you so much, Jan-Niklas and Michael, for sharing your expertise this evening with us. Really learned a lot. I think, as we can see in the chat as well. Super excited. Before we jump off, where can people learn more about you? And is there something like some advice that you would like to give to our audience or the Angular community in general? Maybe Jan-Niklas, you go first. Wait, let's unmute you. You're still
muted.
Yeah. Wait. You have to unmute yourself.
I just did it a second before, and then first of all, lucky Michael, because I'm kind of overwhelmed by this question, and he has now like 5 more minutes to think about it while I'm coming up with something ad hoc. So one thing that is definitely interesting is the new RFC process in the Angular repository. This is definitely cool. Creates more transparency about the project, and I really like them. I don't know if there's like a tag or anything like that, but most of them are like labeled with RFC. So I would definitely check those out. It's also a good handle for the community to have influence on the Angular project itself and how it develops. This is definitely cool. And another thing I would recommend is the Angular community Discord channel. A lot of GDEs, core team members are there, and I'm glad that I destroyed Michael's idea. So have fun with coming up with something. Okay, I should now wrap up. Angular Discord community channel. There's a Twitter account. Check it out. Go to it. Have fun, Michael.
Well, how can you learn better Angular? Of course, I have plenty of ideas in my head now. One of them that I should mention first before I go to all the others is, of course, there is an official GitHub repository, but there is also the docs page. And on the docs page, you can find blog posts from the team. So in your face, Jan, I managed to find something.
Yeah.
Second thing, I have something more. Give me a second. We have YouTube, we have Google, we can Google about Angular. You can watch talks about Angular on Vimeo too, for example, or you can buy books. Books are like this paper stuff with printed like letters, it's called. And yeah, you can also learn it. Sorry, I have no clue.
So you just need to have a lot of them in your background, so you're well covered in that area, right? So thank you so much. Sam is posting all the links on also in the chat so that people can reach out and copy paste them from there. So again, thank you so much. We really had fun. I hope everyone in the chat also had fun. We learned a lot, and we hope you all had a great time joining as well. So with that, thank you so much for joining. Have a great evening or a great day if you're joining from the US, and stay safe, and see you in the next episode. Bye.
Bye.